Okay, so today we're going to be looking at converting improper fractions into mixed numbers. Now we're going to have 3 examples in total. We're going to start with an easy one. Hopefully we can use that to develop our understanding, and then we'll get on to slightly harder questions. Okay, so the first question we're going to look at is convert five halves into a mixed number. Okay, so we're going to use this one to illustrate a few points. You may be able to do this one straight away. Okay, so first of all, we want to get 5 halves into a form where we have a whole number and a fraction. Okay, so instead of writing it just as a fraction, we're going to have a whole parts and then fractions. So a way of thinking about this is how many wholes go into that 5 halves. Okay, well, 2 halves is a whole. Okay, so 5 halves is made up of 2 halves plus 2 more halves. That would take us to 4 halves plus 1 half. Okay, so you've got 2 halves plus 2 halves plus 1 half. Well, we know each of these is equal to 1, so that must mean that these two are the same as 2. Yeah, that's 1 add 1. And then we have plus an extra half. Okay, this here can also be written as 2.5. Okay, that is how we'd go about writing 5 halves as a mixed number. We have taken a slightly longer route, but I want us to think about what we have done here. We're looking at how many times 2 goes into that 5. Okay, well, 2 goes into that 5 twice. That's where this 2 comes from. And then there is 1 left over. That's where this 1 comes from. Okay, so we're going to have a similar question, slightly harder this time. We're going to look at, so the question is going to be the same. We're going to convert 131 over 3 into a mixed number. Okay, so we could do like we've done here and look at how many wholes go into that by taking away 3 each time. We're seeing how many 3's go into that. Or we could think of it as a division. Okay, we need to remember that every fraction can be written as a division like this. Okay, now we're going to take you back to primary school maths when we do this. We're going to do bus stop method, and this time instead of getting a decimal, I want us to stay with a remainder. Okay, so let's have a bit of side working here. We have 3 into 1, 3, 1. How many 3's go into 1? Does not go. Remainder of 1. So now we've got 13. How many 3's go into 13? Well, that's 4 with a remainder of 1. How many 3's go into 11? Well, 3 times 3 is 9. So it's going to be 3, remainder 2. Okay, so we know that 131 divided by 3 is equal to 43, remainder 2. Okay, this here is a useful form for it to be in order to convert it into a mixed number. Okay, we know that there's 43 wholes with 2 left over. Well, what are they? They're 2/3 that are left over. Okay, so you can think of the answer of 131 over 3 written as a mixed number would be 43 and 2/3. Okay, so the 2 comes from your remainder, 43 comes from here, and your thirds will always, your denominator will always match what the original was. Okay, so let's have a look at one last example. Okay, we're going to have convert 567 over 12 into a mixed number. Okay, this time we've got a slightly nastier number at the bottom here. We can do bus stop with this 12, but we'll end up carrying quite a lot in this, or exchanging a lot of units into the next column. So what I'm going to do is quickly do a divisibility check to see if this can be simplified. Okay, well, the first one to check would be 2. Is this top number divisible by 2? No, it does not have a factor of 2, as it does not end in 0, 2, 4, 6, or 8. So the next thing would be 3. If you remember, your divisibility check for 3 is to do the digit sum. So we're going to do 5 add 6 add 7, which gives us 5 plus 6 plus 7. So that is 13, 18. Is 18 in 3 times table? Yes. So this must be divisible by 3. So I'm going to do a little bit of working to simplify this out. Okay, so over 12. Let's simplify this. So we know that 12 divided by 3 gives us 4. And now we're just going to quickly do a little side working to divide this by 3. So 3's into 5, go once, remainder 2. 3's into 26, go 8, remainder 2. 3's into 27, go 9. Okay. So I've simplified this to make our denominator a nicer number to divide by, okay? So just in case you're wondering, or you cannot see here, I've divided the top by 3 and the bottom by 3. Next up, I'm going to do exactly the same process as I did here. So I'm going to do 189 divided by 4. So 4's into 189. Well, 4's into 1, do not go, carry the 1. 4's into 18, well, the closest is 16, so that's 4. And that has a remainder of 2. How many 4's go into 29? Well, 28 is 7 times 4, so that's a remainder of 1. So this is 47, remainder 1. So if you remember, 47 is going to be our whole number. 47 is our whole number. And then our fraction part is going to be this as our numerator, so that's 1. And this is our denominator, quarter. So 567 divided by 12 is the same as 47 and a quarter.